Hello, we are going to talk about equations. Right, to get some idea about what an equation is, let's think of one or two simple problems. Now, suppose there is a number, right? Now, we don't know what this number is, but we know that if I add 2 to this number, I will get 5. So let me write down this problem like that. There's a number. I'll just use a blank to show that. We know that if we add 2 to this number, we get 5. So that looks just like a simple arithmetic problem. Fill in the blanks. 1 plus 2 is equal to 5. And we know that the answer is 3 because 3 plus 2 is equal to 5. Now the idea is to think about this using algebra to develop, to make up some rules that will help us to find the answer to such a question, even when the problem is quite complicated. So let's see how to do it. Now, let me clean that away. So we have this problem where a number, an unknown number, plus 2 is equal to 5, and we are supposed to find that number. Now, the algebra method is to say, right, we have this unknown number, we are going to call it something. Let it be x. So x is our unknown. We don't know what it is, we're just going to give it a name, and we usually use a letter to name it, so let's call it x. Now, and I have this thing here which says x plus 2 is equal to 5. So what we really have here now is an expression in algebra. So x plus 2 is an expression, and we have an equal sign, and we have a 5, right? And this thing here is called an equation in algebra, right? Where we have an equal sign, and we have an algebraic expression on one or on both sides. So this is a statement in algebra which tells us that one expression on the left side is equal to another expression or number on the right side. Now there are rules that can help us find the answer to such equations, even if the expression is quite complicated. So to see what these rules are, let's do it. Let's work out this answer using the rules. Right. The idea is we want to find x. Right. Now we have a 2 there, which is sort of in the way, because if we don't have the 2 there, then all we have is the x, and that's the answer. So the idea is we can think about trying to get rid of the 2. Now the way to do that for an equation is to subtract the 2. That means that on the left side we minus the 2. Now the rule is that if we do something to the left side, we must do the same thing to the right side, so that the left side is still equal to the right side. Right? That's what equation is about. Let's try that. So I'm going to say I have x plus 2 is equal to 5. Now I will minus 2 from both sides. Alright, so at first x plus 2 on the left side is equal to 5 on the right side. Now if I minus 2 on the left side and I also minus 2 on the right side, then the left and the right side should still be equal. Okay, but let's see what happens now. If I have a x plus 2 minus 2, 2 minus 2 is 0. So I have just x left on the left side, and on the right side I have 5 minus 2, which is 3. Look at what we have now. We have x equals to 3, which we know is the answer. So it seems like a rather abstract and complicated way of getting the answer when we already know that the answer is 3 just by looking at this blank up there. But let's move on to slightly more complicated example, and you'll see when it starts getting useful. Alright, when the equations get really complicated. So let's move on by trying a slightly more difficult question. Let's do something like 2 times blank is equal to 8. So 2 times what is equal to 8? In this case, we know the answer is 4. These are small numbers and we can easily think of the answer. Alright, 2 times 4 is 8. So the answer must be 4. Let's do it the algebra way. Now, once again, let me clean away the 4. So we have this blank, this unknown number that we must find. 2 times 1 is equal to 8. Let me give it a name. Let me call it A. Alright, so 2 times A is equal to 8 and we want to find A. So in algebra, if I have 2 times A, I can write it as 2A. I can leave out the times sign. So what we have here is 2 times A is equal to 8 and we want to find A. Now once again, like in the last example, we can think of it this way. We have a 2 times A there. Now we really like to have just the A on this side, because if it's just A on this side, then we already have the answer. So 2 is in the way. Alright, if we can somehow get rid of the 2, we would have the answer. How do we do that? Now we have a 2 times A here, so we could get rid of the 2 if we divide the left side by 2. Right? If we do this, 2A over 2. Divide that by 2. But of course, in an equation, to make the right side equal to the left side, if I divide the left side by 2, I must also divide the right side by 2. So now, let's simplify that. On the right side or on the left side, we can cancel. Alright, so we divide by 2 and on the top and divide by 2 at the bottom. Get 1 and 1, and then only A is left. On the right side we have 8 over 2, which is 4. So we get A is equal to 4, and that's the answer. Right, so what we have seen is that we have seen two simple techniques that can be used to find the answer to an equation. We have seen this way of subtracting the same number from both sides. We have seen how to divide both sides by the same number, and we can actually apply this method to quite complicated equations just repeatedly to find the answer. Right, let's move on. Okay, so another problem might be, for example, y divided by 3 is equal to 2. Okay, so that's slightly less obvious. What divided by 3 is equal to 2? I'm sure you can think of the answer. If you try out some numbers for the y, you will find that 6 is the answer, right? Because 6 divided by 3 is equal to 2. Okay, let's do it using the rules of algebra. So once again, we start from the idea that it would be nice to, if we had just the y on the left side without the 3 at the bottom. If we had just the y, then y is equal to the answer, and we know the answer. So we want to get rid of the 3. In this case, we have y over 3, and the way to get rid of the 3 at the bottom of a fraction is to multiply that fraction by 3. Let's do that. Let's do 3 times y over 3, and we must do the same thing to the right side. 3 times 2. So now, on the left side, we have 3 on top and 3 at the bottom. We can cancel this, right? Divide that by 3 and divide that by 3. So we get 1 on top and 1 at the bottom. So we are left with y. And on the right side, we have 2 times 3, which is 6. And we already know that it's 6, right? 6 divided by 3 is equal to 2. And using this rule of doing the same thing to both sides, we can find the answer. Alright, let's now do something slightly more difficult. Let's do a question that has a minus sign. Right? Minus sign is always a little bit more confusing. So if we have x minus 2 is equal to 5, let's see how to find x. So we start again with the idea that it would be nice to have just x on one side, and we should try and get rid of the minus 2. We we can do that if we add a 2 to both sides. Let's try that. X minus 2 plus 2 is equal to, and we also add a 2 on the right side. Now the reason why we should add a 2 is because we have a minus 2, with a minus 2 at first. So if we add minus 2 to 2, you'll get 0. They will cancel. So on the left side we have just x, and on the right side we have 5 plus 2, which is 7. So there we get our answer. Right. Now let's go on to something slightly more difficult. Right, now in this equation, 2x plus 1 is equal to x plus 4. Notice that we have x on both sides of the equation. Right, in the example just now, I only have x on one side, and it's quite easy to guess the answer. Right, x minus 2 equals to 5. You can guess that x is 7 because 7 minus 2 is 5. Now things are going to get a little bit more complicated. If we have x on both sides, it would be slightly more difficult to guess the answer. You could still try, of course. So let's see how we can apply the rules of algebra to find the answer. Now, so just now I have said that it would be nice to have just x on on the left side, and we should try and get rid of all the other numbers around x. So that was the idea that I described just now. But now we have an x on the right side as well. Okay, and the idea is that we really want the x to be just on one side. Otherwise, it's no point having an x equals to an expression that also contains x, because we don't know what x is. Okay, we really like to have just the x on one side and just numbers on the other side. Then we can have x is equal to that number. So the first step then is to get rid of all the x on one side. Right, how do we get rid of the x? Well, in just the same way as before, we minus the number, we minus the x. So let's try that. I have an x there and a 2x there. I want to get rid of the x on the right hand side. So I'm going to minus x from both sides. Now, it might sound a little bit abstract because we don't even know what x is. So it's as if we are subtracting a symbol, a letter. But the idea is to think of this letter, think of the x as really just a number. It's just a number that we did not know. But as long as we are subtracting the same unknown number, as long as we are subtracting the same x from both sides, we know that we are subtracting the same number, even though we don't know what that number is. So that's alright. So let's do that. Right, I'm just going to write a minus x next to it to save me having to write out everything. So on the left side, I'll have 2x plus 1 minus x. Okay, I can do 2x minus x to give x plus 1. And on the right side, I have x plus 4 minus x. So x minus x is 0. and I have just 4. So now it's looking simpler, looking like the example earlier where we have just the x on one side. So x plus 1 is equal to 4. We can do that. You can even guess right away that 3 is the answer because 3 plus 1 is equal to 4. Well, let's just apply the rule that we have learned. X plus 1 is on the left side. We want to get rid of the 1 so that we have just x. And we can get rid of the 1 if we minus 1 from both sides. So I'm going to say, right, if I minus 1 on the left, the 1 is gone and only x is left. If I minus 1 on the right, I have 4 minus 1. And 4 minus 1 is 3. Now at this point, I'm going to show you something. If you compare this equation with this equation, notice that the 1 there, it is as if the 1 on the left side has moved to the right side. Alright, there's a 1 on the left there, now it's gone, but a 1 appears on the right side. But the 1 on the right side has gained a minus sign. So the plus 1 on the left side has moved. It is as if the plus 1 on the left side has moved over to the right side and changed sign. So this idea is often used as a rule or as a method in algebra. That the idea is that you can instead of thinking of it as subtracting 1 from both sides, you can think of it as transferring or moving the 1 to the other side and then changing the sign. So this is one way that people often use when they do equations. Now I personally prefer to think of it as subtracting 1 from both sides because it's just as easy, and that is the real reason. Alright, if you think of subtracting 1 from both sides, we know that that's the right thing to do because you're doing the same thing from both sides and left side is still equal to right side. Of course, you can also think about it as moving 1 from there to there and then the sign changes. Right, that would also work. But I do have many students which simply remember this rule without understanding that they are really subtracting 1 from both sides. And the trouble with this is that when the equations gets more difficult, they get quite confused. Alright. Now let's move on to a even more complicated expression, just slightly more complicated, an expression with a bracket. Here we have 2 times the bracket of x plus 1 is equal to 4. Now there are 2 ways you can do this question. One way is is to remove the bracket. We know how to remove the bracket. Just multiply the number outside the bracket by each term in the bracket. And then it would look just like the earlier example. Now I'm going to do it in a slightly different way, which would actually make it simpler. I'm going to say, right, 2 times the bracket of x plus 1. The bracket of x plus 1 is really a number. Okay, if you know what x is and you add it to 1 in the bracket, you get a number. So we really have 2 times a number is equal to 4. Now I'm going to say it would make things easier if I can get rid of the 2 first. So since I have 2 times a number, I can get rid of that if I divide both sides by 2. So what would that look like? If I divide both sides by 2, it looks like this. The whole of the left side is divided by 2, and the right side also divided by 2. Then I can cancel the 2, divide by 2 at the top and divide by 2 at the bottom to give 1. So now the 2 is gone. So on the left side, I'm left with x plus 1. And on the right side, I have 4 over 2, which is 2. So now I have quite a simple equation. X plus 1 is equal to 2, and you can already guess that x must be equal to 1. Okay, and if we follow the rule, I would subtract 1 from both sides. That gives 2 minus 1, which is 1. Right, now let's look at something even more complicated, just by a little bit. Equations with fractions. Right? Fractions are always more complicated than just whole numbers, because it has got a number on top and a number at the bottom. So in this case, we have x over 2 plus 1 is equal to x over 3 plus 2. So how do we do this? The idea here is that you can think of it this way. Now, wouldn't it be nice if we can somehow get rid of the numbers at the bottom? If we can do that, then the fractions will be gone. They will become just numbers. How can I get rid of the 2 there and the 3 there? In a fraction, I can actually get rid of the 2 if I multiply it by 2. Right? If I multiply that by 2, the 2 and the 2 cancels. But of course, if I multiply it by 2, if I multiply the left side by 2, I have to multiply the right side by 2 as well. Okay, that's one idea. But even if I can get rid of the 2 there, I still have a 3 there. Right? The 3 is not going to cancel with the 2 if I multiply the right side by 2. So to get rid of the 3 on the right side, I really need to multiply the right side by 3. Alright, multiply the right side by 3. So this is what we are going to do. We are going to multiply both sides by 2 and by 3. And then we'll get rid of both the 2 and the 3 at the bottom. So let's try that. Now, so I want to multiply the left side by 2 and by 3. And I want to multiply the right side by 2 and by 3. Now this is the point where we must be very careful. Let's look at the left side. The way I have written the expression, it looks like I'm doing 2 times 3 times x over 2, and then plus 1, meaning that I'm multiplying 2 by 3 by x over 2 first, and after that I add the 1. Now, that is wrong. That is wrong. The reason why it's wrong is that if you go back to the first equation, you see the left side is x over 2 plus 1. That means that x over 2 plus 1, x over 2 must be added to 1 first before we multiply by 2 and 3. So you see the difference. The way I've written it is like I must multiply 2 and 3 by x over 2 first before I add the 1. But in the original expression, I must add 1 to x over 2 first before I multiply by 2 and 3. Now the answer will be different, right? So what this means is that when I multiply by 2 and 3, I must make sure that x over 2 plus 1 happens first. And there is a simple way to make sure of that. Brackets. Right? To be very safe, all I need to do is to put brackets around the original left side, as well as brackets around the right side. So that ensures that the plus and the times are done in the right order. Okay, so let's simplify this expression. Now I have 2 times 3 times this bracket. We know what to do when we have a bracket. We have to remove it, and when we remove the bracket, we have to multiply the number outside the bracket by each term in the bracket. So the number outside the bracket is really 2 times 3, which is 6. Right, 2 times 3 is 6. So I'm going to multiply by x over 2 to get one term. 6 times x over 2 plus 6 times 1, which is 6. And here I have x over 3 times 6 plus 2 times 6. So we multiply the number outside the bracket by each term in the bracket. So now we can simplify it. Okay, so just to emphasize the point, why adding the bracket makes it different. If I did not add the bracket, I would just have 6 times x over 2, and the number there would still be 1, if you remember. Alright, but after adding the bracket, I get a 6, so that's different. Okay, let's simplify that. 6 times x over 2. So 6, let's cancel, divide by 2 there, I get 1, 6 divided by 2 is 3. So I get 3x plus 6 on the left side. On the right side, x over 3 times 6, let's cancel, divide by 3, I get 1, 6 divided by 3, I get 2. So x times 2 is 2x, plus 2 times 6 is 12. Now it's beginning to look simpler. There are no more fractions, which is very good, and we can now apply our rules to solve the problem. Okay, in the next step, you see that we have x on both sides of the equation, and it would be nice if I can get rid of the x on one side first. So on this side we have a 2x. We can get rid of that if we minus 2x from both sides. Let's do that. 3x plus 6. I'll minus 2x from the left side, and I'll minus 2x from the right side. So on the right side, I only have 12, the number 12 left. And on the left side, I have 3x plus 6 minus 2x. Okay, we know that 3x minus 2x is x. X plus 6 is equal to 12. Right? So that's what we get after we do 3x minus 2x. That's what we get. And it's looking quite simple now, and you can even guess that x is 6 because 6 plus 6 is 12. So let's carry this through. Alright, we want to have just x on one side. So to get rid of the 6, we subtract 6 from both sides. Left side minus 6 and the right side minus 6. That's what we get. So the answer is 12 minus 6, which is 6. Now, equations can often happen when we have problems in the real world. So let's look at an example. Suppose that I have a room, a rectangular room. So this rectangle there represents the floor of that room, and this is the width of the room, and this is the length of the room. Alright? Suppose the problem is this. We are given that one side is longer, right, that's the room, than one side is longer than the other side by 2 meters, and we are given that the perimeter of the room is, say, 20 meters. So the question is, find the size of the room. Right, find the size. Find the length and the width. We can do this using equations. Right? The way to do it in algebra is to say, right, we need to find the sides, so the sides are the unknowns. Now there are 4 sides. Okay, 2 of the sides, the longer sides are the same, equally long, and 2 of the shorter sides are equally short. And we know that one side is longer than the other side. Right? It's longer. Right, one side is longer than the other side. See there? By 2 meters. So we have 2 unknowns, the length and the width. So let's give this some name. Okay, 2 unknowns would make things a little more complicated. So let's start with one of them. Let's start with the width. Let me call it, okay, let the width be x. So I give the letter x as a name for the width. Okay. So the width is called the width is called x. Now in the next step, we have the other quantities. We have the length and we have the perimeter, and the way is to try to relate these to x. That means to write them using x. For example, the length. Now the length, what do we know about the length? We know that one side is longer than the other side by 2 meters. Alright, so the length is the longer side and is longer than the width, which is the other side. So the length is longer than the width by 2 meters. Now we know that we have just called the width x. That means the length is longer than x by 2 meters. So length, and I can write that idea as an expression in algebra. I can say that the length is x plus 2. That means that the length is more than x by 2 meters. So I have an expression there. Okay, so I've just related x to the length. Next, the perimeter. That's the next bit of information. 20 meters. So perimeter means the sum of all the sides of the room. Okay, so we have let's see, perimeter. We have two widths and we have two lengths. Alright, we know that the width is x, so to make it more obvious, let me write this down. So this width is x, that width is also x, that length is x over 2, sorry, x plus 2, that length is also x plus 2. So the perimeter can be written using x, or as we say in algebra, can be written in terms of x. If we just add all these together, if we add x to x plus 2 to x plus 2, let's do that. X plus 2 plus x plus 2. Right. So we have written the parameter in terms of x, and we can simplify this first before moving on. Now you have x, and x, so the x is added 4 times here, so that simplifies to 4x, and we have a 2 and a 2, so x 2 plus 2 is 4. Okay, so that's the parameter in terms of x. Now how do we solve the problem? How do we find the size? Okay, now we know that the parameter is 20 meter, so that means that this expression there, 4x plus 4, should be equal to 20. There we have an equation, finally. And we know how to solve this equation. We know how to use this to find x using all the rules that we have learned just now. Let's do that. So this time x is on the right side, but no problem, we just follow the same ideas. We say that, right, we would like to have just x on one side, in this case the right side. So let's start by getting rid of the other numbers. Now the other numbers is the 4 there and the 4 there. Which number should I get rid of first? We need to do it one by one, because 1 is added with a plus 4 there, we have a times 4 there. Now it is easier to get rid of the plus 4, because I can just minus the 4 from both sides. It is more tricky to get rid of, if you want to get rid of the times 4 first. Alright, because to get rid of a times 4, in this case is 4 times x, so it is a times 4 there. I need to divide both sides by 4. But if I divide both sides by 4, I must divide both the 4x and the 4. Right? You must remember that if you multiply or divide one side, you have to put that whole side in a bracket, like in the example just now. Okay, because you're supposed to add everything on that side first before you multiply or divide. So we should get rid of the plus 4, because that's easier. So let's do that. Let's minus both sides by 4. So minus the right side by 4, the 4 is gone. minus the left side by 4, we get 20 minus 4. Okay, so that would be 16. 16 equals 4x. Now that's definitely a lot simpler, and you might even guess that the answer is 4, because 4 times 4 is 16. So let's do it the algebra way. We have 4 times x on the right side. So since this is a times 4, it is x times 4, we can divide that by 4 to get rid of the 4. So let's do that. If I divide both sides by 4, I will have x, right? The 4 on the right would be gone if I divide the right side by 4. And on the left side, I have 16 over 4. 16 over 4 is 4. So we have our answer that x is equal to 4. Now if we look back at the earlier part of the working, x is supposed to be the width. So this means that the width is 4 meters. Okay, so that's the width is 4 meters. And we know that the length is longer by 2 meters. So the length is 4 plus 2, which is 6 meters. Therefore, the sides are 4 meters and 6 meters. So it's a room that is 4 meters by 6 meters, and that's the answer to this question. We'll stop here. Thank you.